Hi everybody, this is going to be our 4.1 notes, vertex form of a quadratic function. So our goal is to compare the standard and vertex forms of a quadratic function. So we have looked at this in the grade 10 academic, so if you're not sure, let's do a quick review of the three different forms. We just spent the last unit doing factored form. So that was when we had f at x or y is equal to a, x minus s, x minus t. And what can we figure out from factored form? Can we figure out the direction of the opening? Well, if I knew a is positive or negative, then yeah, I can figure it out. So yeah, it tells me the direction of the opening. Does it tell me the vertex? It kind of does. We have to do a little bit of work. Same with the axis of symmetry and the optimal value, because if I know the vertex is just, by adding these together, dividing it by 2, and then finding other values, yes, it does tell me that, but I have to do some work for this. So it's not as straightforward. And then I can find the x and y intercepts. We just make y equal to 0 for this, x equal to 0 for this, and we can solve for it. So we were able to do all this stuff with factored form, and we were able to find this information. We just had to do a little bit of work. Looking at standard form our equation was ax squared plus bx plus c, like this. Can we figure out the direction of the opening? Same as over here. As long as we know it's positive or negative, yeah, we can figure out the direction of the opening. Can we figure out the vertex? Not just by looking at it and not by doing some work. We have to do a lot of work involved to get this information. X and y intercepts? Yes, we can get the y-intercept pretty easy because you just make x equal to 0. But for the x-intercepts, we have to do a little bit of work. So we have to, not so clear from standard form. The way we're going to be looking at for this chapter now is vertex form, which is y is equal to ax plus h squared plus k. And this might look familiar to some of you. If you took the grade 10 academic, you've probably seen this before. Or you might have just seen it before for some other reason. But our direction of the opening we can know from the a value again. Oh, ran out of lead. The reason why they call this vertex form is because the h and the k value tell us the vertex. So it tells us the vertex. Check. That's a check mark. Okay, that's a check mark. Axis of symmetry. Well, if I know the vertex, that's x and that's y, the axis of symmetry, x is equal to the h value, and the optimal value is equal to the k value. Then I can also figure out the x and y intercepts, just like we did over here by setting x equal to 0 and y equal to 0. So based on all three of the equations, I can figure out the most stuff from vertex form. Again, I can figure out the vertex, that's what we call it vertex form, by getting the h and the k value, that's going to be the vertex. The axis of symmetry, remember, is just the x value of the vertex. And the optimal value is a max or min point, and that's the k value of the vertex. And then the x-intercepts, we set y equal to 0, and for the y-intercepts, we set x equal to 0. Just fixing that mistake there, which I'm sure many of you caught, but we're screaming at the screen, but here we are. So this form tells us a lot, and we're going to be able to go from this form to this form. But first we're going to practice, can we go from this form to this form, and can we understand the information in vertex form? So we are going to complete the following table in example 1 here. We're going to find all this stuff from vertex form. So equation 1, oop, that's a little piece of that's lying there, that's weird. All right, so vertex, remember, is h and k. So I'm just going to write that just above it. X minus h squared plus k. Please note that the squared is on the outside of this bracket here. Sorry, writing it up here. It's on the outside of this bracket here, this exponent. Remember, it's a quadratic. So h is here, k is here. Notice the sign. The sign is for 2, even though there's a minus in here. So whatever it is in here it's the opposite sign. The reason that is we did this before, where if I have 3x minus positive 2, a negative and a positive here are going to be a minus. So that's why it becomes x minus 2. If this was a negative 2, like up here, these two negatives are going to make it a positive 2. So whatever it is on the inside of the brackets, it's the opposite. Whatever's on the outside of the brackets is going to be the correct sign. So plus 1 for this, it's minus 2, but it's the opposite for the value of x for the vertex, or the h value. So the axis of symmetry is just the h value. H is equal to 2, therefore the axis of symmetry is equal to 2, x is equal to 2. Is there a maximum or a minimum value? Well, look at the a value. In this case, it's 3, which means it's positive, which means it's going to open upwards. If it opens upwards, we have to have a minimum. For the number of intercepts, we can look at the a and the k values. If a and k are the same values, or sorry, the same signs, notice here that a is positive and k is positive. A is positive, k is positive. This is our example where we would have a parabola above the x-axis, so there are no x-intercepts. And then because of that, we can get our domain and range. Remember, when I have a quadratic, the domain is always this, and then the range is based on the maximum or the minimum value, or the optimal value. So on the vertex, we have a minimum here of 1, so y has to be greater than or equal to 1. So if this was my graph, my minimum is at 1, so y has to be greater than or equal to 1 because my graph is always greater than or above 1. I might try drawing this a little bit bigger, maybe on a separate piece of paper or something, but let's carry on to the next example. So now we have a vertex of h and k again that we want to get from this. Notice no brackets. We'll even just put that little no brackets. If there's no brackets here, that must mean there is no h value. So if there's no h value, well, we can't have just no value. For a vertex, we're going to say that value is 0 because there is no brackets. We have an x or a h value of 0 for the vertex. And the k value is the number just still outside of the bracket, so there's no brackets, just the number on the end. And that keeps the sign, so it's -5. So then we think, what's the axis of symmetry here? Just the x value of the vertex, that's x is equal to 0. And now we look at the a value. Well, is a positive or negative here? It's half, so a is greater than 0, which means it opens up, which means if it opens upwards, and I'm just getting a scrap piece of paper right now. So if it opens upwards, I know it's going to have a minimum because it opens upwards. So if it opens up, the lowest point is the minimum value that it can go for. Okay, so the number of x-intercepts, sorry. You look at the a and the k values again. Here, a is positive, and k is negative. So a, k are opposite. So in this case, I drew this graph, but this graph is wrong. I was just showing as an example. So what this must mean is that the graph has to open upwards. So it has to go up like this, going upwards. But the k value is negative, which means my vertex has to be at -5 somewhere. So even if it was like over here, well, it's 0, -5 based on my vertex, then it must be going through the x-axis at least twice. So we're going to have 2 x-intercepts. So I just sketched the graph. I don't know what these x-intercepts are yet, but we can figure it out later, but I know it's going to have 2 x-intercepts. So the domain for any quadratic is always x is any real number, and then the y value is any real number, but y, because we have a minimum, y has to be greater than the lowest point, and our lowest point we said was -5 for the y value. So y has to be greater than or equal to -5. Remember, greater than or equal to, because it can be -5, but it has to be -5 or above. All right, next one. So we have -2/3 bracket x minus 4 bracket squared plus 8. So I'm gonna just rotate this like this. All right, so our vertex still h and k. So remember, the value on the inside, whatever the sign is, it's the opposite of that. So it's -4 in here. It's going to be +4 for the vertex. And the k value is whatever it is. So if it's +8, it's going to be +8 for the vertex. Axis of symmetry is just the x value of the vertex, or the h value of the vertex. You know what I mean. Do we have a max or a minimum? Well, we have to look at the a values. A value positive or negative? A is less than 0, which means it's got to open downwards. It's got to go downwards if A is negative. Again, I just drew this randomly. This is not this. I'm just showing it's going downwards. So if we have it's going downwards, the highest point is going to be called the maximum. So we're going to have a maximum here. So then we're going to look at the number of x-intercepts. So let's look at the a and the k values. A is negative, k is positive, which means the maximum is going to be a positive y value. So if the k value is a positive y value, meaning the highest point has to be somewhere on the positive part, like up here, it's going to be 8, 2, 4, 6, 8, it's going to be up here, and it's opening downwards. Well, I'm going to have 2 more points where I'm going to be crossing the x-axis. So a and k are opposite, so we're going to have 2 x-intercepts. That's an a there. So our domain for quadratic function is always x is any real number, and then the range is going to be y is any real number. But what's the maximum point we said? The highest it'll go to is 8. It's the highest point. So y has to be less than or equal to 8. So notice my signs here. If it's opening upwards, if it's positive, you can think of it going this way. This is for positive a. This is for negative a. Remember those signs. All right, last one. We have -3x plus 5 bracket squared. So notice there's nothing on the outside of this bracket. Very similar up here. If we don't see that part anymore, that k value is going to be 0 because there is no part after the bracket. Inside the bracket, I see +5. Remember, it's got to be the opposite of that. So it's going to be -5. I mean, they could just put +0 here, but why would they put that in there, right? So we have to know it's going to be 0. So the axis of symmetry, just the x value. -5. Do we have a maximum or a minimum? Well, a positive or negative? I know some of you are already doing this. You're like, oh, I already know this. I get this. Good. A is going to be less than 0 because it's negative. It's going to open downwards then. Very similar to what we saw over here. going to open downwards. So we're going to have a maximum point. And then the number of x-intercepts. Well, A is negative, and K is 0. This is a weird one. If I have K is equal to 0, what that means on my graph is, special graph, over here. What it means is, if K is 0, then it hasn't moved up or down on this y-axis, so it's going to be like here, opening down, in our case. Could be a case where it's like this and it's opening upwards. But in either case, when K is equal to 0, there's only going to be one x-intercept, and that's going to be right at the vertex. So the vertex here makes sense because, x-intercepts happen when y is equal to 0. So there's only one x-intercept, it's going to be the vertex in this case. And then we can look at our domain and ranges again. Same thing. Domain is any real number. Our range always starts off the same. Y is any real number. But we said because we have a maximum, our graph mainly resembles this one. This one. What's the highest point then that's going to go to? Well, it can only go to this spot and everything below. So y has to be less than or equal to 0, which is just the k value, my optimal value. And it has to be less than that because we have a negative a value. So we're always going to have it less than here.